Hello there. Today we will start the topic waves. So let's first define a wave. A wave is a disturbance that carries energy. So wave is defined as a disturbance that carries energy. Right. So let's first look at an example to understand what exactly a wave is. In this animation, you see a man throwing a ball towards his friend. So when he throws this ball has a mass and it has been given some velocity. And hence, this ball carries some kinetic energy with itself. So when he throws this ball, he not only throws this ball, he's actually throwing some energy towards his friend. Now in this case, while the energy moves, some mass is also getting transferred because the ball has moved from his hand to his friend's hand. And so we see that there was some energy transfer as well as some mass transfer. Now, in a case when there is no mass transfer and strictly energy is transferred from point 1 to point 2, then we say that a wave has moved from point A to point B. So, a wave is a transfer of pure energy, and hence its definition that wave is a disturbance that carries energy. Now, waves are classified under various categories depending on different criteria. The first classification is that of whether or not the wave has a pattern. If the wave has a pattern, then it is called a periodic wave. On the other hand, if the wave lacks a pattern, then it is said to be a non-periodic wave. So what does having a pattern mean? Having a pattern means that the wave repeats itself after regular intervals of time. So when this happens, the wave is a periodic wave. Whereas if the wave is randomly generated, that is, there is no time periodicity in the propagation or generation of that wave, then the wave is said to be a non-periodic wave. Can you think of an example for non-periodic wave? Well, think about what distinguishes noise from music. In music, you see a pattern of sound which repeats itself, whereas noise is just randomly generated sound. So, noise is an example of non-periodic wave. In fact, noise is name given to any sound which is non-periodic and hence is not very pleasing to hear. Periodic waves have numerous examples. As just discussed, music can be thought of as a nice example for periodic waves. Right. Next, there is another category which is based on the criteria whether or not the wave requires a medium to propagate. So waves which require a medium are called mechanical waves. So mechanical waves are those waves which require a medium for their propagation, whereas non-mechanical waves are those waves which do not require a medium for propagation. Let's again think of some examples. How about light? We know that light travels from sun to earth. Now, we also know that there is absolutely nothing present between earth and the sun. What I mean by that statement is that there is absolute vacuum. So there is no medium available for propagation. That is why light is a non-mechanical wave, because it does not require a medium for propagation. For mechanical waves, the simplest example is that of sound. We will discuss this shortly in this chapter, that sound is a disturbance that travels through a medium. In fact, the sound we hear is a disturbance that travels through air. Now, if there is no medium and hence there are no particles, then the disturbance cannot propagate, and hence without a medium, sound cannot move. So, if you're in vacuum and even if you're shouting at the highest possible sound that you can generate, nobody would be able to hear you, because sound requires a medium for propagation. The next criteria is based on whether or not the energy moves. On the basis of this, waves are classified as stationary or traveling waves. Now, stationary wave is a wave in which a disturbance is created, but that disturbance is localized to an area. That is, that disturbance does not move out of the region in which it was created. A simple example of this would be when you disturb a stretched rubber band. Let's look at this animation. So when this rubber band is pulled and left, it starts to vibrate. Now, if there was no damping, this rubber band would vibrate forever. But notice that the energy which is carried by the disturbance in this rubber band never moves out of the region in which it was generated. And hence, this is an example of stationary wave. Right. Now let's think about traveling waves. What about when you throw a stone in a pond? Look at this animation. So when the stone hits water, it transfers some energy to the surface of water. But does this energy stay there? No, right? As soon as it is transferred, the energy spreads out and moves in every possible direction. That is why this is an example of traveling wave. So stationary waves are those waves where energy is localized to the region. The disturbance does not move. Whereas traveling waves are those waves in which the disturbance which is generated due to energy moves out of the region where it was generated. Right. And the final classification is on the basis of the direction in which the particles of the medium move. On the basis of this, waves are classified as transverse or longitudinal waves. Now, transverse waves are those waves in which the medium particles oscillate perpendicular to the direction of propagation of energy. Let's look at this animation for example. The energy is traveling from point A to point B. So, the direction of movement of energy is strictly horizontal. But where do you see the particles moving? Let's spread this string into a collection of particles. Now, look at each particle. The energy is moving from A to B in a strictly horizontal direction. But what are these particles doing? They are moving in the vertical direction. Also note that each of these particles never changes its horizontal position. It only moves in a strictly vertical motion. And so, this is an example of transverse waves. Now, in case of longitudinal waves, the particles vibrate in the same direction in which energy is getting propagated. Let's look at an example of the same. The spring is held from one end. Now it is continuously being pushed and pulled. Look at what happens to the spring. We see certain regions which are highly compressed and certain regions which are elongated. And these regions are not fixed. Let's look at a specific region, for example. Now, you see at this instance, there is a compression at that point, which means that spring is very tightly wound. But After a while, we see that now there is a stretch in the spring. In that region, we see that spring is now stretched. So, in this case, if you look at, again, let's look at the spring as a collection of particles. What do you see the particles doing? All of them are vibrating horizontally. Notice that they are not moving vertically, and also that their mean position remains the same, which means they oscillate, but on an average, they remain where they are. Again, in this case, mass is not getting transferred, and hence this is a wave. So, this was an example of longitudinal wave. So, the difference once again between transverse and longitudinal waves is that in transverse waves, the particles move perpendicular to the direction of propagation of energy, whereas in longitudinal waves, the particle vibrate in the same direction in which energy is propagating. So, this far we have understood that wave is a disturbance that carries energy. Then we saw that there are 4 categories in which they are divided based on different criteria. If there is a pattern in the wave is called a periodic wave. If it lacks a pattern, then the wave is called a non-periodic wave. If the wave requires a medium for propagation, then it is called a mechanical wave. Whereas, if no medium is required, then the wave is a non-mechanical wave. Then, wave is also classified on the basis of whether or not energy moves. If the energy and the restricted to an area, then it is a stationary wave. Whereas, if the energy travels, then the wave is called a traveling wave. And finally, if the particles oscillate in the direction of propagation, it is a longitudinal wave. Whereas if particles oscillate in the direction perpendicular to the propagation of wave, then it is a transverse wave. This brings us to the end of this session. I leave you with this animation which shows you an example of each of these waves. Thank you.